So this is asking for the mean of the monthly fees for, what is this, single rooms. That sounds like a heck of a deal in this day and age, doesn't it? So all these, when it's asking for a mean, it's asking for an average. And an average is you just take up all the values, add them together, and then you divide by the number of data points that we're looking at. So we have 5 different room rates. So we need to add them up: 370 plus 310 plus 380 plus 340 plus 310. And then you take that sum and you divide it by how many room rates we're looking at, which is 5. And I'm not going to do that work by hand because this is definitely where we'd use our calculator. When we do this, we get 342. So there is your answer. Okay, so it's a pretty straightforward problem once you know exactly what they're asking you to do. And then you can, if you made a mistake on this, it might have been you plugged in a number wrong, or you tried to do it in your head and you just kind of, if that's the case, just take the time to plug it into a calculator so you can get the exact answer. All right, very good on that. Okay, so we've got mid-segment theorem we're going to talk about today. Before we jump into that, I want to remind you, and we talked about this yesterday, but all work and test retakes must be turned in by Tuesday at midnight. So that means this weekend is the best time for those of you who are missing a lot of homework assignments. This weekend is the best time for you guys to just take some time, get caught up on those, get that half credit back, which will help you more than you think. And if you are planning on doing a test retake as well, it's a good time. It's a good idea to let me know that. I will get you signed up for the retake so that you can do that at your leisure, and maybe you wait until Monday or Tuesday before you actually do the retake, but you can let me know. Maybe this weekend you go through everything, you determine which test you're going to do the retake on, and you can let me know on Monday and Tuesday. So I just want to keep emphasizing that so that you're bringing that grade up as high as you can before grades are submitted for this quarter on Wednesday. All right, now on to today's lesson. We've got a paper cup. You can just see that right here. We're going to use this paper cup as a funnel. So what we do is, first of all, it's filled to the brim, and the circle of water on the surface has a diameter of 2.5 inches. Then we tear a hole in the bottom, and we drain the water out a little bit at a time. When the water is halfway down the funnel, the draining is stopped. And what's the diameter of the circle of water on the surface now? And you can answer if and when you're ready, just what your intuition tells you. All right, so I'm recording again now. And I know this is set up almost as though it's like a trick question. So maybe some of you were looking at it and trying to figure out what's the trick. But I asked you just what's your intuition, and that's exactly right. So when that was just explained, so if the water is going down, and now let's kind of illustrate what's going on. So here's your circle at the surface level, and this diameter is 2.5. So now the water comes down to, let's say this is a halfway point on each side. And we have this new circle. Your intuition would say it's going to be half. And in this case, your intuition is exactly right. There are some tricky things with cones, and there could be questions related to this where it doesn't work out quite like you think. But in this particular case, it does. All right. So hopefully, and I ask this not trying to trick you. I ask you because I hope at the end you're saying to yourself, oh, that's exactly what I thought it would be, and it turned out to be right. And I hope that's what you're thinking right now. Okay, so this is related to our theorem of the day, and this is called the Mid-Segment Theorem. I'm just writing a note down real quick. So let me move us ahead. And this is the main idea. We know about midpoints. So if you have a segment The midpoint is the point right in the middle, and it divides this segment into two congruent segments. Okay, so if we're good with that idea, and we've used it before in this class, if I took a triangle and created midpoints for all three sides, so something about like that, then this creates this scenario where I can connect those midpoints together. These segments that I create are called mid-segments. And you can see each triangle has three mid-segments, and this diagram very clearly shows where all three of them are. Now the mid-segment has a particular property. And before I guess we jump into that, I wanted to remind you that when we're looking at the cone had a cross section that was a triangle. And so if we take the midpoint and connect it, turns out we saw that this diameter right here is half of the diameter up above, and that's what we're about to talk about. So if a segment joins the midpoints of two sides of a triangle, I'm looking in this box now, then the segment is parallel. First of all, it's parallel to the third side. And this makes sense if we think about water level. The water level is flat up here, and when we drain it down, the water level is still going to be flat. So these two are parallel to each other. Okay, and then so the mid segment is going to be parallel to the third side, and it's going to be half the parallel side's length. And this diagram right here kind of summarizes everything. So we've got a few ideas encapsulated in this theorem. We've got midpoints, which separate into congruent segments right there. So that's going to be an idea that we need to remember. We've got parallel lines shown right here and here. So the fact that we have parallel lines, we've already worked with parallel lines in the past, and we're going to see how that comes back into play. All right. And then the other thing is, of course, maybe the thing that stands out the most is the fact that this mid-segment, if this mid-segment is x in length, then the parallel side is going to be twice as long. And that's the key idea, that the parallel side is twice as long as the mid-segment is. And vice versa. That means the mid-segment is half as long as the parallel side. So hopefully so far so good. It kind of works intuitively for everyone. Let's look at this right here. And before we kind of dive into problems dealing with this, I wanted to show you an informal proof. If we were in person right now, I would hand out triangles to everyone, and you guys would take the time to fold these and kind of show this proof. It's not a formal proof, but it's an informal one. So imagine you could find the midpoint of two sides. So we've got a midpoint here and here. And you find those midpoints, and then you just folded it in half along this line, the mid-segment. Now, once you folded this over, it would look like the next diagram, right? And notice that we create these two triangles down here when we do that. So I can fold both of those triangles over, and notice in the next two diagrams, that's what we've done. We folded those two triangles in, and we can see that this segment, we created a rectangle. This segment on the top and this segment on the bottom are congruent. But now, let me kind of erase some of my markings. If I unfolded it, notice that this is my crease line right here. And now I've got these two congruent segments. Oops, I'll just do one mark on that. So I've got those two congruent segments for each of the triangles. Now, if I kind of project this up, this line right here, then on the top side, I can see that those segments are congruent in that way. So this might or might not completely make sense for you, but hopefully you're following along. Notice that the mid-segment, which is this top line right here, consists of a smaller segment and a longer segment. But the parallel side consists of two of the longer segments and two of the smaller segments. So this informal proof kind of shows us why this mid-segment is going to be if this, if I'll make up a number, if that's 3 centimeters long, then this has got to be twice as long because I've got the 3 right here, but then I've got between these two segments right here, that makes up another 3. So the total length is, I'll just do it this way. The total length is going to be 6. All right. Hopefully that was not confusing and you were able to follow along. And it's helpful to have that in your hand. You can actually fold it and you can like flip it back and forth and see, but I think it's clear enough as we're working with it. So for the rest of the class, if you look in the top right corner, I'm going to have this diagram here, which you can use for reference. All right. And I'm making a note to myself for something real quick. All right, I've got that. So let's look at this. These are actually problems that are already solved for us. And so we can look through and we can see we are solving for X and for Y. And they give us a couple of values. And we can see that we've got midpoints here and here. So now that means that this 8 right here, if this is 8, then this congruent segment has to be 8 also. And you can see there's an explanation. X must equal 8 centimeters because of the midpoint. And Y must equal 9 centimeters because the mid-segment is exactly half its parallel side. So if this is 18, again, it's just dividing it by 2 and we get 9. So that's how we get the answer for the mid-segment. Just like we did with that paper cup. All right, so if we look at the next problem, I'm just gonna kind of go through the explanation that they put below. So X, in this case, must equal 76 degrees because we do have, these lines are parallel. And if these are parallel, then if I look at this 76 right here and this X, we can see right here, those are corresponding angles. And we've already learned that corresponding angles are congruent. So it's again, a relatively straightforward idea if you can remember that, that idea about corresponding angles and that these are parallel lines. Y has to equal 14 because, again, if the mid-segment is 7, I just take that and multiply it by 2, which gives me 14. So the calculations here aren't too difficult for the most part, though they can get more challenging, and we're going to see that more on Monday, I guess. All right, if we look at the last one, if this entire length here is 18, X is the mid-segment for that side. So X is exactly half of 18, so it's 9 centimeters. Y is this one right here, and Y must equal 8 because it is equal to half of the full side of 16. So this only gives us the length, that 8 is only for that. So if I look at the entire length, because those are congruent, those are both 8, that means the entire length is 16. And therefore Y has to be half of it, 8. So hopefully none of this is throwing you off yet. So I wanted to show you something real quick. If I come over here to this example, this is a triangle and I can manipulate this triangle around. I can change the shape of it. You can see that I'm going to get these mid segments for all of them. So I've got all 3 mid segments given. So I'm going to rearrange this real quick. All right, and I want to bring this right here. And notice now I'm going to look at this side from A to B. And A to B, you can see right here, has a length of 4. And you can just count it on the graph. And what I wanted to show you is the mid segment has to be half that length, which is 2. And you can see, you can count up the 1, 2 right there. But no matter where I move C, this will always be true. So if I bring this in and C is now sitting right here, notice that the mid segment is still 2 in length. And now let me go to an extreme. If I go all the way out here, stretch this triangle out big time. So it stretches it out, but still look at the mid segment. It's still just 2 in length. So that's what's really good to know is that no matter where I move this, if you just pay attention to the mid segment while I move this around, Notice that that mid-segment never changes in length. All right. And hopefully, this is enough of a demonstration to kind of prove the point. So there you go. We can always count on this mid-segment theorem being true. So with that being established and hopefully good to go, let's move forward. And I'm going to do about 6 practice problems. And I mean, some of them I'm going to have you guys do and put the answers down, but I'll get you started. And then that's what our plan is for the day. And I wanted to say at the beginning, there will be some problems that might be challenging for you. Maybe none of it's challenging for you. We'll see. But on Monday, we're going to get some more practice with this. So if you are looking at your homework over the weekend for this and you're not getting it, luckily Monday, it's going to be more of just this, no new content. And you can, work with me and we can figure out where your troubles are. So let's just jump through this. I need to solve for X and Y for each problem. And a lot of times it doesn't matter which one I do first, but oftentimes it's best to start with the X. Well, let me take that back. It doesn't matter. I just tend to start with going alphabetical order. So this X right here is marking an angle. Notice how it's in a corner. So that's going to be an angle. And the 86 right here is another angle. And those happen to be, just like we saw before, that would be our corresponding angles because these are parallel to each other. That's according to our mid-segment theorem. So now, if those are corresponding angles, then X has to be 86 degrees. Okay, for Y is the mid-segment, and its parallel side is 24 centimeters in length. So all I need to do is take that 24 and divide it by 2, and that'll give me 12 centimeters. And we're good to go. Those are the answers. As we're going through, and I know I say this from time to time, but if there is a particular problem that you don't understand how we got the answer, then you can kind of mark that down. So if 1A didn't make sense, just have a piece of scratch paper and say, okay, 1A, I want to come back to that one. You can hang out after class. We can go back over this problem and we can work individually with it. So if I look at the next one, it doesn't seem like I have the information I need to answer everything. Let me start with X, because that one actually we're good to go. This is the mid-segment, and this is the parallel side for the mid-segment. And we know that, again, if I look up here at this diagram in the corner, if my mid-segment is X, in this case 8, then I have to multiply it by 2 to get the parallel side. So I'm just going to do 2 times 8 to get 16, and there's my answer. X is going to be 16 centimeters. Y is this angle up here, and it's not a corresponding angle. So we want to make sure that's clear. This is a corresponding angle to 70, but Y is not. So I need to kind of think through this in a different way. And what I hope you can notice is that, I'll get rid of all this work here. All these segments are congruent, the ones that I just marked in red. So this segment and this segment are congruent, and this segment and this segment are congruent, and they're all congruent to each other. So we created a type of triangle here. Does anyone remember the name of this type of triangle? All right. No worries. It's Friday. I'll give you guys a pass. This is an isosceles triangle. So you want to be on the lookout for that. If you have an isosceles triangle, this is going back to one of those rules we learned 2 units ago, back in unit 2, that is. So this angle is 70. We learned that the base angles of an isosceles triangle are congruent. So if that's 70, that means this one right here has to also be 70 degrees. So if these two are 70, now let's focus on this big triangle that we've got. And the big triangle has 3 angles in it. They are 70 and 70 and our unknown angle y. So this is going to be 180. So 70 plus 70 is 140. And now I can just subtract 140 from both sides, and y will be 40. So some of these angle relationships are going to come back into play, which is why we learned it when we did, so that we're set up for the rest of the semester anytime we have weird stuff like this going on. Okay. Again, I'm going to assume everyone's good to go. If you have any questions, feel free to jump in and stop me. But let's go through 4 remaining problems. And I think some of these we can do a little more straightforward. In fact, I am not going to answer these. I want to see if you guys can do these, and just write in your answer where you see the blanks right here, and then we can talk about it. Okay, so I don't know if you care explaining or not. How did you get 7 for x? And anyone can answer.
Isn't it equal, like that whole line where 7 is equal to the other x?
You got it. We can see the congruency marks, so that's exactly right. All right, and I see this, I mean, this is 20, I'm assuming, right here. So how do we get 20?
Because 10 times 2 equals 20, because the 10 centimeters is half of y.
There you go, perfect. And again, you can constantly be looking at this reference up here in the corner. This is not the most difficult theorem in the world, but it is good to have a reference just so you can remember all the different little features associated with the mid-segment theorem. So yeah, we just double it. Very good. All right, let's look at the next one. Just clear all the markings. And again, you guys can try and figure out what the missing values are. Okay, I'll just kind of talk through this one real quick because, well, it's for x at least, because x, it's kind of the same thing that we saw before. So nothing really different going on with that problem. Pretty much the same thing as before. For y, what did we have to do in this case?
I did 14 divided by 2. Is that right?
That is correct. Very good. Because we know the parallel side, the mid-segment is always half as long. And again, just a visual on that will always kind of make it clear enough, because we can see that obviously this side is much smaller than that side. So we can think, okay, it can't be bigger than 14, so therefore I need to divide by 2. Okay. Hey, why don't you raise your hand? Let me know you're here. Okay, let's look at this one. One of these we should be able to do pretty quickly. One of them we might have to take a little bit longer to look at and process. So I'm going to see if you guys can figure out one of these, and then, well, yeah, let's just do that. Figure out y first of all, and then I want you to think about how you would solve for x. So I don't want to talk too long about y, because that's another one that's pretty much the same as before. If we know the parallel side, when we solve the mid-segment, we need to divide that by 2. And dividing by 2 in this case, we get a decimal, so 6.5. So that one, just quick run through there. But what does anyone have an idea of what we need to do to solve for x?
Does it have something to do with the 62 and then like same side interior angle, sort of?
That's a really good thought. That is a good thought. But the reason that won't work, and I do like where your mind was going, the reason that won't work is because the same side interior angles are inside these parallel lines right here. So here's a parallel line, here's a parallel line. So your same side interior angles are like those two, or these two. And I'm not trying to say they're congruent. We know they're not. But I'm just trying to connect 2 angles. So those are your same side interiors. But you're thinking through it. Any other thoughts on it?
Would be 62 plus 55 plus x equals 180.
You got it. That is it. Okay. Does anyone remember the name we have for that? 62, 55, and I'm going to go ahead and put an X right here. All right, this would be an example of using the triangle sum theorem, TST. So if I do this real quick, that's 117, I believe. And then I can subtract the 117 from both sides, which I believe gives us 63 as our final answer, 63 degrees. Now, the reason I know that 63 is just my final answer is, remember, these two right here, where the X's are, those are corresponding angles. This is parallel to this. So we've got some corresponding angles in this diagram. I'll go ahead and write that up to the side. And we've got triangle sum theorem down in that bottom triangle. And that's how we can get it. Are there questions on this before we look at the last one? Okay. The last one right here, we've seen one similar to this already. So you can just plug in whatever answers you can find for X and for Y, and we'll just run through it in just a few minutes. So I don't know if you're willing to share how you came up with your answers on that. And if you prefer not to, you can just chat at me that no thanks. All right. So I'll just run through this. I will say this is not the answer I got. So I'm not sure how that one was found, but I'm not trying to say that it's bad. There might have just been a different way of approaching it, and there was a slight mistake. So we know this is 68, and because we saw this diagram already, we know that this is an isosceles triangle. So we know that the base angles are the same, 68 degrees. And of course, we also have seen this a few times now that these two angles right here are going to be congruent because these are corresponding angles. So no calculation required. Once we know that this is 68, we can kind of work our way through and figure out that this has to be 68 degrees as well for X. But now we can see if this is 68, now let's focus on the big triangle. And we could do this with the small triangle, but we've already got these angles. I've got a 68, 68, and Y that make up the angles there. So 68 plus 68 plus Y all have to add up to 180 because of the triangle sum theorem. And I'm not going to do all the math for that. You guys can work through the equation, and you can figure out that Y does have to equal 44 degrees. Okay, that's basically it. Now, I wanted to point out that you've got a PDF in Canvas that you're going to look at tonight. And I wanted to show that to you real quick, because you will see some problems that you'll probably be able to do just fine. So all the ones that have the red circle are the ones you need to do. And some of these you'll look at and you might say, okay, no problems there. Let me just find the answer and you're good to go. But when you come over to these three, these might be more challenging for you. We didn't do any practice with this today. I wanted you guys just to try this. Notice that they give you expressions here, 2x plus 3 for the mid-segment, 5x plus 1 for the parallel side. So what I want you to do is I want you to try those. If you don't know how to do it, on Monday we're going to look at more problems that look like this, but I'm giving you a chance to just try it before we go through it as a class. So give it your best shot. If you don't get it solved, not a big deal. We can work on that more on Monday. So having said all of that, if you have any questions on this, some of this might not make sense for you. If that is you, stick around and ask questions. If you are good to go, have a wonderful weekend, and I will see you on Monday.